This video will discuss the addition of alcohols to aldehydes and ketones. The addition of alcohols to aldehydes and ketones is a very useful way of protecting the specific carbonyl. We'll worry about protecting in just a moment, but here's an example of an aldehyde reacting with methanol. The reaction itself requires acidic conditions and it will form an acetal. As an aside, a single alcohol adding to an aldehyde or ketone forms a hemiacetal. Now, hemiacetals are unstable yet sometimes very common. For example, glucose exists in a hemiacetal form. Back to acetals. So we can use diols to make cyclic acetals, which are really good as protecting groups. Alternatively, we can also use dithiols to also make these thioacetals. So what do we mean by protecting groups? Well, let's see it as an example. Let's say we wanted to make this compound with a ketone and an alcohol in it from a acetone molecule and a Grignard. Well, it would be impossible to make this Grignard right here because the Grignard would react with itself. We would have the Grignard attack the carbonyl. So this is not an ideal approach. However, it can be done if we use a protecting group on that carbonyl. If we start with this keto halide and we protect the carbonyl by making a cyclic acetal, for example, we will yield this species, this acetal. Now that the carbonyl is not there, we can react it with magnesium to give us our Grignard without any effect on that protected carbonyl. That protected carbonyl, Grignard, can now react with acetone to give us our expected alkoxide, which upon addition of an acid, which we need anyway in the workup, will get rid of the protecting group or the diacetal to yield us with our desired product.